Hey everyone, and welcome. Today we're diving into something huge, a really fundamental problem in artificial intelligence. We're going to break down some incredible research from Google that totally flips the script on how AI learns. And you know what? It might just fix one of AI's biggest, most frustrating flaws. So let's jump right in.
So imagine this for a second. You've got an AI that can pass the bar exam, write beautiful poetry, and code like a pro. But what if every single time it learned something new, it forgot something it already knew? It sounds like a bad sci-fi plot, but it's a very, very real problem for the AI models we all use every single day.
You know, the researchers behind this work use this perfect analogy. They call it a kind of digital amnesia. Specifically, it's like a condition called anterograde amnesia, where a person just can't form new long-term memories. All they have is their past and whatever's happening right this second. And honestly, that's shockingly similar to how today's AI models work. They have this massive library of knowledge from their training, and they can handle the conversation you're having right now, but they really struggle to truly learn from that conversation and make it a permanent part of what they know. This massive problem has a name, and it's called catastrophic forgetting.
And this chart just lays it all out, plain and simple. Our brains, they're constantly changing, rewiring themselves through neuroplasticity. It's how we learn, day in and day out. But LLMs? Well, they're pretty much set in stone after their initial training. They can't just absorb new info into their core knowledge without risking that, you guessed it, catastrophic forgetting. We've got to find a way to bridge this gap.
So for years, the mantra in deep learning has basically been, go bigger. You know the drill. Add more layers, throw more data at it, use more computing power. And hey, don't get me wrong, that's given us some incredible results. But we're starting to realize we're kind of hitting a wall. Just making these things bigger and deeper, it's not solving this fundamental memory problem.
So why isn't just piling on more layers the answer? Well, this research points out a few key things. For one, more layers don't automatically mean the model can think harder or do more complex calculations. Sometimes the improvements are tiny, and a lot of the time, the model just settles for a good enough solution, not the best one. But here's the kicker. It does absolutely nothing to fix the real problem, letting the AI learn continuously and adapt on the fly. We need a totally new way of thinking.
And that, my friends, brings us to the hero of our story, a completely new paradigm called nested learning. The core idea is to stop seeing an AI as one giant, single thing. Instead, nested learning says we should see it as a whole system of smaller, interconnected learning processes, all working in harmony.
Now, to really get nested learning, we have to talk about something called associative memory. It sounds fancy, but it's super simple. It's just the ability to connect two things together. You see a face, you remember a name. You hear a song, you remember a moment. In AI talk, it's just about mapping some inputs, the keys, to some outputs, the values. It is the absolute bedrock of learning.
And this right here, this is the first huge aha moment from this research. The big insight is that everything inside an AI model is, in some way, a memory system. I mean everything. Not just the obvious parts that store data, but the actual structure of the network, and even the rules we use to train it. They're all just different kinds of memory trying to connect keys to values.
There's this quote from the research blog that just nails it. We've always thought of a model's design and its training rules as two totally separate things, right? Well, nested learning says, nope, they're actually two sides of the same coin. They're just different levels of the exact same process, learning by making connections. And that is a radical shift in how we think about this stuff.
So how does this all actually work as a system? Well, think of it like a set of gears all turning at different speeds. You've got the fastest, inner gear. That's like the attention mechanism, constantly spinning, processing what's happening right now. Then you have a slower, middle gear. These are the training rules, or optimizers, which update pretty often to learn from recent mistakes. And finally, you have the biggest, slowest gear on the outside. That's the AI's core knowledge, the stuff it learned in pre-training, and it only updates every once in a while.
Okay, so this is a really cool theory, right? But what can you actually do with it? Well, this is where nested learning stops being just an idea and becomes a powerful new toolkit for actually building better AI.
This new way of thinking leads to two amazing innovations. First up, deep optimizers. You know the training algorithms that help a model learn from its mistakes? Well, by thinking of them as memory systems, we can make them way smarter, turning them into these powerful multi-layer modules that get way better at remembering and learning from past errors.
And second, there's the continuum memory system. So instead of just short-term versus long-term memory, we can build a whole spectrum of memories, all updating at different speeds. Kind of like how our own brains work, right?
Of course, talk is cheap. The researchers had to prove that all of this actually works in the real world. So they built a brand new model called HOPE. It's a self-modifying architecture built from the ground up on these principles. This is basically the first big field test for the entire nested learning idea. So, how did it do? Let's check the scoreboard. When it comes to understanding language, we use a score called perplexity. Just think of it this way. A lower score means the model is less perplexed or confused by the language. It's better at predicting what word comes next. And as you can see, HOPE gets a much lower score. It just has a much better grasp of language, period.
But it's not just about predicting the next word. What about actually thinking? Well, on a whole bunch of common-sense reasoning tasks, where the AI has to really understand a situation, a higher score is better. And guess what? HOPE comes out on top again, beating the baseline model. This shows that the benefits go way beyond just memory. They're about deeper reasoning too.
So what's the big takeaway from all this? It's simple, but it's huge. By seeing a model's design and its training rules as the same thing, nested learning opens up a whole new way to design AI. We're not just stacking layers to build taller models anymore. Now, we can build deeper levels of learning to create much, much smarter models. And that leaves us with one last, pretty mind-blowing thought. This research gives us a real, credible path to AIs that can actually learn from their experiences without forgetting the past. So I'll leave you with this question. If every single conversation you have with an AI helps it learn and grow for good, how does that change our relationship with this technology? It's a profound question, and one we might have to answer a lot sooner than we think. Thanks so much for joining me for this explainer.